Thanks, Varun, for having me. Well, I'm Henning, originally hailing from Germany. I'm a mechanical engineer and economist by trade. Built my entire life infrastructure projects, a lot of coal-fired power plants, cement plants, steel plants all over the world. Left Germany around 18 years ago, moved to Australia, spent a lot of time in India, in Indonesia, in the US, and came to China around 15 years ago. I had various positions in China, served as an executive for a large German corporation and built actually cement plants along the Belt and Road Initiative, often also together with the Chinese government on EPC projects. Very interesting projects, but we were creating a lot of CO2. So I wanted to leave the CO2 creating world and actually redeem my guilt. So we started an electromobility company that we exited after a year. And the past 6 years, I have been building Enpal, a large German residential electrification company that focuses on rooftop PV, energy storage, heat pumps, smart metering, mobility charging, and everything combined into a virtual power plant and actually arbitrage trading energy for our customers. Very successful. The company scaled to roughly $1.2 billion in revenues. I'm still serving on the board of Enpal, but since April, I'm the CEO of EnerVenue and responsible for building the company into a global battery leader.
Fantastic. And energy storage now is a global buzzword. It's seeing a lot of action. So, just tell us about what are the differentiating factors that EnerVenue today brings in its products, in its technology, and what are the latest offerings, especially for the next gen storage, which is now where the industry is interested in.
Sure. So EnerVenue's heritage is actually, we took a NASA technology into Stanford University, incubated the technology there, and we spun it off, which is now EnerVenue. So we call the technology an aqueous metal cell. It's a water-based electrolyte based on a nickel hydrogen technology that actually stores electrical energy into chemical energy by a chemical reaction where we turn water-based electrolyte into hydrogen and reverse this chemical reaction, which in the end results in a battery that has an extremely long life cycle. We can charge and discharge roughly 30,000 times over 30 years. We have no fire risk from thermal runaway based on the water-based electrolyte. We do not have any fire risk there. Plus, we are very temperature resilient on a system level from -10 to +45 degrees. We can do that without really difficult thermal management. And we are running a supply chain that is material abundant. Our battery does not consist of rare earths or lithium. We use nickel. We use water-based electrolyte. We use a little bit of steel and composite. And therefore, first of all, a circular economy. Most of the battery, roughly 95%, can be recycled. And it can also be produced local for local in a world that needs more and more energy independence on country and regional level. I think we are very well positioned to build a global player that produces local for local.
So, there are a lot of new chemical compositions which are now coming up in battery, and the industry is looking beyond lithium. But how does these kind of batteries, play out on two aspects, which the customers always look for? One is the cost of storage, and also in terms of the stability of the technology itself, whether it comes to reliability, life cycle, and the performance. So how does your tech, stand up or compare against the other tech which is available?
Yeah, we create a new battery category, which we call the infrastructure grade battery. That means most of the technologies that are available in the market right now are degrading after 5, 6, 10 years and need augmentation or replacement. Our battery more behaves like infrastructure. So like a transformer, like a grid. It is there with close to no maintenance and is actually cycling and stabilizing grids or its consumers. When it comes to cost, we are focusing very much on the life cycle cost. So the key metric that we are looking at is levelized cost of storage, whereas the CapEx is, I would say, to other non-lithium technologies, very competitive. So if you compare, for example, flow batteries, we are outcompeting in many areas, flow batteries, when it comes to energy efficiency, to CapEx, to OpEx, to recyclability. There are many areas where we are actually very confident about a positive product market fit.
And any major projects, any major deployments that you would like to mention?
Yeah, we are building right now our 250 megawatt hour fully automatic production line. We just raised an investment round of $300+ million. And we're using the money basically for three things. We are doubling down our research in Fremont, California. So we are developing the next generation of electrochemistry there. We are creating the automatic production line, which is a huge CapEx investment for us. And we are developing our commercial deployment capability. So we are building global teams to obviously introduce the technology to our customers, to deliver and manage it for our customers in markets. When it comes to, I would say, to those deployments, we have various pilots in the markets. We just, I think last month, published a new pilot project together with our partner Towngas, where is a DC bus charging station that we are equipping with our batteries. We have pilots coming up right now in Australia, in Belgium, in Saudi Arabia, in the US. So basically all over the globe, and going now into large-scale deployments of our batteries.
And in terms of, since you're talking about, building your manufacturing capability and setting up global teams, how are you going about planning your global market expansion? Are there any key markets that you're currently looking into? Are there any top priorities in terms of the new markets?
Yeah. So I think all markets that have certain market segments that have certain challenges when it comes to safety, when it comes to maintainability, when it comes to multi-cycling a day, are very interesting for us. So Middle East is interesting for us with harsh environment, high temperatures. We are outcompeting other chemistry. China, obviously very interesting with massive capacities on renewable energy and grid stabilization technologies, where often, for example, lithium-based technologies are not allowed by government regulations anymore. Australia, very interesting market where batteries are being part of the grid already and searching for new technologies with longer life cycles, lower levelized cost of storage. And then obviously the big area I think that we're all excited about is data centers. Our battery is perfectly positioned for primary power balancing on a data center, but also on the UPS, on the uninterrupted power supply for a data center. And this is where we are doubling down our research as well and our deployments as well.
Fantastic. And since you mentioned a lot of different usage areas, you mentioned about battery usage in charging, in mobility, in data centers. What does your product roadmap look like? How are you going about product innovation basis the application areas?
So we are launching right now basically 4 products. So we call it the Energy Rack, which is a 150 kilowatt hour block that can be deployed in various areas, but it's for, let's say, an in-house installation, so in a warehouse or in a covered space. Then we have what we call the Energy Core, which is a UPS application. It's a 30 kilowatt hour stackable product. And then we have what we call the Energy Prism, which is a 20-foot DC block container. All of those we can AC integrate as well and offer turnkey solutions. The fourth one is what we call a high power cell that is still in discussion and in the roadmap. where we basically increase the C rates of the batteries and target a different market.
And today, when you are competing, manufacturing strength, manufacturing capabilities, manufacturing capacities, I think that becomes a very key aspect. So tell us about how you're going about planning your manufacturing strength, supply chains, and capabilities, maybe in the medium term and in the long term.
Yeah. EnerVenue, as I just mentioned, was born out of Stanford University as an American enterprise, but right now we are creating EnerVenue and transforming it into a global business. So we keep our research in Fremont, California, but having our first high volume manufacturing in China. And I think here we are trying to leverage the best of all worlds. US on the innovation side, China on its capabilities and infrastructure when it comes to supply chains, manufacturing, and equipment supply. And I think here we are in the center of the Chinese battery innovation, which is the city of Changzhou. And basically within, let's say, a radius of 100 kilometers, you can find everything you need to build a battery factory. You have machine suppliers, you have maintenance, you have talents, you have excess power, you have factories available. And we are leveraging this footprint right now. So the idea is to create a fully automated 250 megawatt hour line until end of August this year. We are well on track with that. We will then scale it until mid of next year to 1 gigawatt hour, and then copy paste this footprint with the machine park, the process know-how, and the technology that we have developed into local markets.
Fantastic. So as we come to the close, do you have any message to your customers, maybe the IPPs, the EPCs, your data center customers? What is the message when it comes to choosing the right batteries and choosing some new chemistries which are out there?
I would say it's really focusing on a lifetime creation, on the value the battery is created over its lifetime. I think in some markets we are still seeing short-term decision making based on capex optimization, but then the bill is being paid 5-6 years down the road. And so to all the customers that hopefully see this podcast, reach out to us if you want to learn more about a technology that can solve your problems for a long period of time.
Thank you, Henning. It was a pleasure being with you, and I would love to have you again into a tech deep dive, on the new chemistry that you're bringing in, and would love to see you again. Thank you for being on the podcast.
Thank you, Varun, for the invitation.